All right, guys, we're going to continue today talking about inequalities. And we're going to add in just a little wrinkle to this. We're going to add in ideas about absolute value and how they affect our inequalities. All right, so after this video, okay, and after you're through this lesson, you should be able to solve inequalities that involve absolute values. All right, so let's jump into it. Okay, so just to review, we've been solving things like this top equation since the beginning of this unit, and we realized that it's pretty much just like solving regular equations, although at the end, the way that we graph it on a number line is a little bit different. So if you imagine, the very first thing I'm going to do is I'm going to add 7 to the other side. Okay, and so let me go over here. I'm going to be left with 3x is greater than 11 plus 7 is 16, and then I divide by 3, x is greater than, let's see, that doesn't go in evenly, but it's about 5 1/3. Okay, so if you imagine, if I graph this on a number line, okay, and I put 5 1/3 right there, and then like 6 is out here, and I'll say 4 is out there. All right, so first of all, this is going to be an open circle, okay, open circle. Let me redo that because that does not look open. Okay, so open circle. And then since I'm greater than 5 1/3, all the numbers greater than are going to be to the right. Okay, so that will be what I shade. Okay, so I'm going to the right. All right, so now let's move on to something that you did back in Algebra 1, and that's solving absolute value equations. Okay, so just a refresher, absolute value, okay, so if you think about a number line and think about zeros right in the middle, 2 and -2, the absolute value of a number is the distance it is away from 0. So in other words, that value is always going to be positive. So for example, the absolute value of -2 equals 2, and the absolute value of 2 is equal to 2, because both of those points are exactly 2 steps away from 0. All right, so let's see how that works when we're solving an equation. So just like before, I subtract 7, I get the absolute value of 2x minus 1 equals 5. Now, here is the weird thing. So the absolute value of whatever is in here is equal to 5. I know then that 2x minus 1 could equal -5, because I know that the absolute value of -5 is also equal to 5. And then I also know that 2x minus 1 could be equal to +5, because +5, the absolute value of that, is also 5. So I have these now 2 equations that I need to solve. And so to do so, I add 1, add 1. Okay, so that brings this one to 2x equals -4. Divide by 2, we get x equals -2. Okay, so that's one of our answers, only one of our answers. We're going to actually have 2. So if I add 1 and add 1 here, I get 2x equals 6. Dividing by 2, I get x equals 3. So my 2 answers are x equals 3 and x equals -2. All right, so this idea of using absolute values is something that we're going to incorporate with inequalities today. Okay, so as I was explaining in the last slide, the definition of absolute value can be thought of as the distance away from 0. So for example, the absolute value of x equaling 5 means that x is exactly 5 units from 0. And that means to the left or to the right. Okay, so in our case, that would mean that x could be 5 or x could be -5. Okay, that's going to come into play with our inequality, so make sure that you understand that we should have 2 answers to our equations. Okay, so the idea of separating an absolute value into 2 separate equations also helps us with, this should say inequalities. Okay, inequalities. For example, let's take the one we were using in the previous slide. The absolute value of x is less than 5. Okay, so let's graph this on a number line, and then we'll talk about how we do this algebraically. Okay, so if you imagine 0 is here, okay, and we'll put 5 out here, and we'll put -5 out there, because we do know that the distance between those is 5 and 5. All right, so what we need to know is the numbers that have an absolute value less than 5. So let's think about what that means in words. That means that the distance from 0, okay, is less than 5. Okay, so if you think about your number line, where on your number line are your values going to be closer to 0 than 5? And so hopefully you realize that if those are my starting points, okay, and they're open because this does not have an or equal to sign, that the values that the absolute value are less than are in between these. So if you want an example for this, take the number 2. Okay, the absolute value of 2 is 2, which is less than 5. Okay, 2 is less than 5. Okay, but something like out here that would be 6, okay, the absolute value of 6 is 6, which is not less than 5. Okay, so our solution would be the numbers between -5 and 5. Now, in the next slide, we'll talk about how this works algebraically. All right, so algebraically, what we're going to be doing is splitting these inequalities into two different inequalities. Okay, just like we did with the equations, okay, we have one equal to -5 and we have one equal to +5. Okay, so with absolute value, okay, I'm going to go, let me undo that. Okay, to get rid of the absolute value, what I'm going to do is I'm going to say that x is less than 3. Okay, because if you imagine for x values that are less than 3, the absolute value is less than 3. So for example, 2 and 1 and 0. Okay, and then what we're going to do is we're going to say x, and then we're going to have -3. But with this -3, we're actually going to switch the sign of what the original one was. So anytime that you incorporate this negative, you have to switch the sign. So it's actually going to say x is greater than -3. Okay, and so just like we did on the last one, to graph this, we're going to go 0, 3, -3. Okay, these are going to be open circles, and greater than -3 is going to be this way, and then less than 3 is going to be this way. So these two things run into each other, and so my solution is just all the numbers between -3 and +3. All right, so they're not always going to be given to us in this easy form. Okay, sometimes we do have to do some solving. So like in this one, we would have to add 2, and so we get that the absolute value of x is less than 7. Okay, and then again, remember, okay, we have to split this into two separate equations. Okay, just like I did in this first one up here. Okay, this first one up here. I need x is less than 7 and x is greater than -7. Okay, so if this is still confusing you about switching the sign, when we switch the sign of the 7, make sure that you ask me, okay, because I can explain it in a bunch of different ways so that you understand. Okay, just to graph this real quick, okay, 7 and -7. And so again, open and open, greater than -7 is this way, less than 7 is this way, so these two things run into each other, so it's all those. Now, what do you notice about the examples we've done so far? Okay, you've noticed that hopefully that when we do this, and 0's right there, that a lot of times we're sending things in between two values. Now, one thing I do want to say is that sometimes we will get instances where we get something there and we get something there, and we actually shade away from 0. Okay, and so those are coming up. Don't assume that every time that we go in between. All right, so let's look at those. So this one is like the last one, except we changed the sign to greater than. So I'm still going to split it into 2, and I'm going to say that x is greater than 3 and x is less than -3. So when we graph this on a number line, this is how it's going to look. 0, and then we have 3, and then we have -3. Okay, both of them get open circles. But now if I imagine, if I'm looking at this one right here, okay, x is greater than 3. The values that are greater than 3 are out here, okay, out to the right of 3. Because if you imagine like 4's out here, 5's out here, and so on. Okay, and then for this one, okay, x is less than -3. So all the negatives less than 3 are going to be to the left. So this is one of those cases I was telling you about where we shade away from the center 0. Okay, so let's try the next one. It's the same one, except I switched the sign again. So now I get the absolute value of x is greater than 7. Split it into 2. X is greater than 7 and x is less than -7. Okay, number line again, 0, 7, -7, open circle, and we are greater than 7, which would be to the right, less than -7, which would be to the left. Okay, now, do not move on until you understand this slide. Okay, because if you don't understand this slide or the previous slide, okay, it's going to be very difficult when we start actually solving complex equations. All right, so now we can actually start solving these things. So we're going to use the same tools that we've been using, and my ultimate goal is to get the absolute value by itself. Okay, so whatever's in the absolute value, get that by itself. So for example, the very first thing I'm going to do is add 3 to both sides. And I'm going to get 2 times the absolute value of 3x plus 4 is greater than 38. Okay, now make sure, okay, you cannot, and I'm going to do this in red because you can't do this, you cannot distribute this in. Okay, so that's bad, so we're not going to do that. Okay, what you're going to do is you're going to divide by 2 on both sides. And now you have the absolute value of 3x plus 4 is greater than 19. Okay, so now once you have your absolute value by itself, this is where you're going to split it into 2 equations. Okay, you're going to say that 3x plus 4 is greater than 19 and 3x plus 4 is less than -19. Okay, so again, remember that you switch the sign. Okay, switch to negative or positive, whichever way it comes out, and then you switch the direction of your inequality. All right, so then let's just solve these. So we go -4, that's a -4. 3x is greater than 15. Divide by 3. X is, greater than 5. Okay, and then for this one, -4, 3x is less than -23. And notice that this one is not easily divisible by 3, so we'll just leave it as a mixed number. So 3 goes into 23 7 times, and this is negative, with 2/3 left over. All right, so on a number line, okay, I always tend to put 0 right in the middle. Okay, off to the right, I have +5, and then off to the left, I have -7 2/3. Okay, 3. Okay, so for this one, again, we have open circles because we're not equal to. Now, the ultimate question is going to be, do I shade together? Okay, so do these both go this way? Or do they go away from 0? So the way to figure that out, okay, if I look at x is greater than 5, So at 5, my values are greater than, okay, and then at negative 7 2/3, my values are less than, so that would be to the left. Okay, so this one is actually shading away from 0. All right, let's look at another one. So same thing, okay, I need to get my absolute value by itself. So I'm going to add 4 to the other side, plus 4, plus 4. I get the absolute value of 3x is less than 13. Okay, now that I have my absolute value by itself, I split it into 2, so I get 3x is less than 13, and 3x is greater than negative 13. All right, cool. So now all I have to do is divide by 3, and I'll have my answer. So 3, and I get x is, all right, so that's going to be 3 goes into 13 4 times, left with 1/3. Okay, divide by 3, x is greater than negative 4 1/3. Cool, so on my number line, put 0 in the middle, and then I'm going to go with 4 1/3, and then negative 4 1/3. All right, and so these both get open circles again. And now, if I'm less than 4 1/3 and greater than negative 4 1/3, that's going to be shaded towards each other. So it's going to be all these values in between. Cool. Next one. All right, so this one's a little bit more complicated. Again, though, you need to focus your attention to what is inside the absolute value, okay? Because we're just trying to get the absolute value by itself first. Okay, so I'm going to add 5. I get 2 times the absolute value of 3 times x minus 2 plus 4. And we're going to say is greater than or equal to, now we finally have an equal to sign. So that will come into play when we do our graphing. So then we're going to divide by 2, and we get the absolute value of 3 times x minus 2 plus 4 is greater than or equal to 8. All right, so we have our absolute value by itself, so we are going to split it into 2 equations. So we're going to say 3 times x minus 2 plus 4 is greater than or equal to 8, and then we're also going to say that 3x minus 2 plus 4, let me redo that parenthesis, plus 4 is less than or equal to negative 8. Okay, so then we just have to solve these like normal. So we're going to subtract 4, and I'm going to get 3x minus 2 is greater than or equal to 4, divide by 3, x minus 2 is greater than or equal to 1 1/3. That's a 3. Add 2, x is greater than or equal to 3 1/3. Okay, 1 1/3 plus 2 is 3 1/3. All right, and then we got to solve this one over here. So minus 4, I get 3x minus 2 is less than or equal to negative 12. Okay, divide by 3, and I get x minus 2 is less than or equal to, let's see, negative 12 divided by 3 is negative 4. Add 2 to both sides, and I get x is less than or equal to negative 2. All right, so here's my 2 points on my number line. Okay, so I go up here, I go 0, and 3 1/3 is out there. Negative 2 is out there somewhere. Now remember that since this is or equal to, that I have filled in circles. Okay, filled in. Now, x is greater than 3 1/3, so that is to the right of 3 1/3. And x is less than negative 2, so that is to the left of negative 2. Okay, and so that's how you would graph that on a number line. All right, let's do one more, and then I'll let you work. All right, so what I want you to do right now is I want you to pause the video. Okay, pause it, and then I want you to try to work this one out on your own. Okay, so I'll give you a few seconds to do that. So pause it, come up with an answer, and then you'll check it with mine as I go through it. No, like really pause it. I want you to pause it. Okay, so hopefully what you did first is you realized that you had to isolate your absolute value. So I'm going to add 8, and I'm going to go 3 times the absolute value of 2x minus 5 plus 4x. And we're going to say is less than or equal to, let's see, 13 plus 8 is 21. And then we're going to divide by 3. Divide by 3. I get the absolute value of 2x minus 5 plus 4x is less than or equal to 7. Now, I have my absolute value isolated, so this is where I'm going to split it into 2. And I'm going to say 2x minus 5 plus 4x is less than or equal to 7. And 2x minus 5 plus 4x is greater than or equal to negative 7. All right, so let's figure this out. So first of all, we have these plus 4x's. Okay, I really don't want to get those to the other side because I want all my x values to stay on the left. So what I'm going to do is I'm actually going to multiply this out. So this is going to be 2x minus 5, or minus 10, because we distributed, plus 4x, less than or equal to 7. All right, so then I can add 10 and add 10, and I can also combine these two like terms all in the same step. So 2x plus 4x is 6x. Adding the 10 to the other side, I get is less than or equal to 17. Last thing, divide by 6, divide by 6. X is less than or equal to, let's see, 6 goes into 17 almost 3 times. So it's actually 2 and 5/6. Okay, so it goes in 2 to get to 12, 5 left over, so it's 2 and 5/6. All right, same thing over here. I'm going to get 2x minus 10 plus 4x is greater than or equal to negative 7. Add 10, and I get 6x is greater than or equal to positive 3. Dividing by 6, x is greater than or equal to 1/2. Okay, so you'll notice on this one that 0 is actually not in between my two values, which is perfectly fine. Okay, if that is the case, it'll come out in the problem. Okay, so if you imagine my number line, now I'm going to have 1/2 on this side because it's the one that's the least, and then I'm going to have 2 and 5/6 over there. Now both of them get filled in circles, filled in circles because we're equal to. And let's see, greater than 1/2, less than 2 and 5/6, so that's going to be towards each other. Okay, so greater than 1/2, less than 2 and 5/6. All right, so that concludes this video. Thanks for watching. Make sure that you start working on your assignment. It's posted in the classroom, and as always, if you have any questions, let me know.